get this feedback saying that, sir, I want to be a developer, I don't want to be a tester. But a tester should know more than what the developer knows. So it is very important that the tester is much better than a developer. So this is what I always feel. And coming from a testing background and going back and again doing a development, I get to see, I think the way we do development is much better because we know that the tester feels these needs. So any day a tester is far better than a developer. Now, what is model-based testing? So model-based testing is a requirement testing where the requirement is given as a model. So a model is something that you can, it's not just a picture alone, but it is an executable. You can run it, give it some inputs, it can give you the outputs, and then you inject the same inputs into your code, which is running on the onboard computer, and then you match these two, and if both of them match, then you say that, okay, your code is the same as the model. The code behavior is the same as the model. So this is very important. And not the model comparison. You have to say that the complete the test case has given you 100% model coverage, and it has given you 100% code coverage. And how well it matches, you will have to indicate beforehand. You don't do it after doing the test. You see that, okay, error is 10. Is it acceptable? You say, okay, we will accept it. It's not like that. Before you do the test, it's simply you have to say that, okay, if it passes with 1% bound, I'm good. And I'm getting a 10% bound, so there's something wrong with my software. This is basically a schematic which talks about the comparison of the model and the code. I'll just walk you through a small example which has happened in one of our missile system, and we lost the missile because of this. So what I have is a limiter there, and there is a discrete filter, and again a limiter or a saturation. The limiter input is limited between plus or minus 20, and output is limited only to plus 9.5. And we designed a set of static tests, to test it out. So the input and the model both were excited by zeros. 0 is a very good input to test, and output was 0. No issues about that. So output was matching between the model and the code perfectly. So there was no issues in this. Now, is it sufficient for a safety critical system to be tested in this manner? So we said, okay, let us do some dynamic tests also. So we ran a sinusoidal waveform with 10 Hertz. We ran through this, and it was matching. The code and model was matching. We said, okay, it's something wrong. Something is not right. So let us run a small 0.1 Hertz signal waveform, do it very slowly this time, and then we realized that the output of the code and the model was not matching. And we had a small error. So if you see this plot, this error is very small, minus 0.6 or something, a very small error which we could say is insignificant. But this was actually a major error where the same variable was reused, and because of this, the missile, shattered. It just broke apart. Nobody got hurt, but this is what happened. So what is important is that you have to have test cases that test the systems. So the test case that you do should be testing your system rather than just the code. So the test case design is very important here. So you should spend a lot of time, I would say some time, better spend a lot of time thinking through that, how you are going to test the system, not just the software alone. Okay. I started on model-based testing with a Fortran model for the LCA program. So we didn't have Simulink and all that. There is nothing like a model there. It was another piece of code. But today we have a Simulink model for the resegmental blocks, which was used to develop the Boeing control law, and we did the model-based test. This is a very recent thing, maybe about 6 months back. A frame-by-frame comparison with a model is a very powerful way of testing dynamic behavior of the system. So the fact that the model and the system, model is a system requirement, it is a direct requirement-based testing. That is the way you should be testing any system. So if you do a frame by frame, every frame I do a comparison and say my model and this matches, I'm very good. So in the LCA context, there was a Fortran code which was used by the system designers themselves. So that was our benchmark model. Even though it is a piece of code, but it's a different language written by the designer themselves, and pilots have flown this, so we had a lot of faith in this code, and we ensured that the LCA aircraft, when it flew, the ADA code matched this Fortran code very closely. The new standard has the DO 331, the model-based supplement. It has brought out certain rules and regulations on the model. So it says that you should have a good modeling guidelines. So if you are going to practice model-based testing, make sure that you have a very good modeling guideline so that you make sure your models are good. You have to ensure that all your system, the simple blocks, the subsystem level or the smallest blocks, they are tested thoroughly. So make sure that you test them very thoroughly, and for our